Hello and welcome to Hacker in the Loop. Today I'm joined by my coworker, Jacob Krell. So he's going to be showing us today how to create an agentic harness that can be used for pen testing and also incorporates Metasploit. So welcome, Jacob.
Hey, thanks for having me. Yeah, with agentic hacking going the way it is, everyone is going into the harnesses. So I figured I'd kind of show you guys how you can make one yourself, and we'll talk through it, and I'll explain kind of what I'm doing as we go along.
That's awesome. And for the listeners too, Jacob's done a white paper on how, AI is being leveraged to do CTFs. He's got a really cool white paper, and we've done some other previous videos on Simply Offensive. So those may be some items you want to check out. So now we're actually getting to see kind of how Jacob's doing stuff. So, and so you said you're using Cursor today to do this, right?
Yeah, Cursor is just what I use. It's kind of an integrated runtime and development environment that makes it kind of easy to spool up these harnesses and use them in production. I kind of have a workflow I go through, so I'll demo that. Usually, I start with doing some like external research. So, for like Metasploit, so I'll ask it like, what Metasploit MCPs are out there publicly? Can we please use them as a template to create our own with expanded feature set? So then, what I also like to do is you want to give it a goal, right? Because the agent needs to know what it's trying to do. So we'll say our goal is to create an agentic hacking harness leveraging Cursor and Metasploit. To that end, please also research deeply Cursor functionality and what we can leverage in doing this. So that's going to quickly go out and run there a little bit. So what I like to do usually is I'll take a tool or an application, and those will usually have an API feature. For Metasploit in particular, it's got gRPC to communicate with it. So then to kind of make a bridge for the agent to interact with that, I like to make MCPs because then it can very easily make tools to wrap those features of either gRPC calls or API calls for stuff like running a scan or looking up in the database or whatever it may be for the application at a pretty generalized level. And they say MCPs are kind of this might be a little too big, the new API level. And I think that's true. MCPs, how I view them, are like the API between the agent and additional functionality. So we had it come back and it did a huge bunch of research. I think that's one of the superpowers of these agentic AI systems is that they can web crawl super fast and just pull information online. So here we can see there's already a bunch of public MCPs. Of note, the official MCP by Rapid7 has only read-only with 8 tools. This is something that I've kind of found across the board as these companies are rolling out MCPs. They're doing it with very limited tool sets. I think that's a risk reduction strategy on their part. For example, like I had Burp MCP once, and I downloaded that and tried to use it. It didn't expose things like the sitemap and stuff like that, though. So I had to extend it to do that functionality, which is easy because it uses like API calls and stuff like that. So really all you have to do is wrap those API calls, like I said, in the MCP. And we can see some people have already gone ahead and done that. Ghost Crew has made one for us. It looks like the most popular, 700 stars, Python, full control 12 tools. So we've got a good base here to build from. And this is already loaded into the context of the agent. So now the agent is going to know all this stuff as we kind of continue building it out. So the first step I always like to do is that kind of initial research section. And it's going through here and it's got all this stuff, right? And if we just scroll down, and then it's going to look up Cursor as well. So we can see here's where it started looking up Cursor functionality. So MCP is primary control plane. Hooks, safety and audit layer. I'll get into explaining hooks here in a moment and how I kind of use them. Rules, skills, sub-agents. Modes, I don't tend to use very often. You can certainly implement that if you need to. Cloud agents, long-running engagements. I usually don't implement cloud agents either. Something you can definitely do. I tend to be cost sensitive. you can start burning tokens really quickly with these agentic workflows. So it's really good to make sure that you're minimizing the amount of LLM like calling that actually needs to be done as the agent is running. Plugin marketplace, blah, 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 blah. So now that we've had it do a little bit of research here, I like to go into plan mode. That's one of the features of Cursor is going into plan mode. Planning, I find, is very effective with the agentic LLMs. They really need to be babied, as it were, into what they're supposed to be doing and how to do it. So if we go into plan mode now, we can say, okay, now with all that information, let's start building out our harness. Please implement baseline hooks, skills, sub agents, and a Metasploit for us as a baseline. So now we'll let it plan out how it's going to do this with the information it fetched. I suppose at this point I can do a little bit of talking about the model while it's going to build our baseline template. I like to stick with Opus 4.6 for security work. Anything past Opus 4.6 I found to be heavily blocked from the API provider, even doing things like scanning code for vulnerabilities and stuff like that. Composer 2.5 is also very good. It's way faster than Opus 4.6. That's kind of Cursor's proprietary model. So that works really well for plugging in directly into the systems we're building, like the hooks and the skills and all of that stuff as well, because it's trained to know how to use that functionality that Cursor has. So yeah, while this is kind of running, I'll let this just run for a little bit. Any questions you have, Phil, at this stage? Sure. I know I'm kind of blasting through this.
Yeah, for folks that are not familiar with Cursor, so why do you use Cursor opposed to just using AI through a browser like you would with ChatGPT?
Yeah, that's a great question. So I actually do use ChatGPT in a browser very frequently. I use that as more of like my personal AI kind of question and answer situation. I like using Cursor because it's an integrated IDE, so you can kind of build the agent and run it from the same location. A lot of people like to use like Claude Code SDK and stuff like that. That works too. The issue is just that is CLI, right? And it doesn't have quite all the features that Cursor does. What Cursor's kind of claim to fame is that it'll index. We don't have any files yet. It's still deciding what it's going to do because we're planning, but it'll index all the files in the repository and then it can dynamically pull those. So like when you're doing a penetration test or something like that, you're going to want to take like massive logs of everything you've done. You're going to want to take like asset inventory. Here's all the discovered hosts. Here's your vulnerabilities and stuff like that. Then just being able to have the agent automagically, as it were, pull that for you saves a lot of work. And I've just kind of found that to be one of the huge friction reducing features of Cursor and why I use it.
Seems like it can help make things a lot more organized than traditional pen testing without AI, because you know how you typically have to keep notes or export to text files or different files and try to keep it organized. It seems like a more organized way to do things.
100%. And it makes reporting really easy too, because it can just pull the information directly out of your command logs and stuff like that. So if we come through here, the planning feature in Cursor will prompt us with a couple of questions. It's going to ask us, where will the Metasploit RPC run for this harness? So I have kind of a unique situation. I run Kali Linux through WSL, which is Windows Subsystem Linux or something like that. There's too many acronyms in this field. But it's essentially just a VM that Windows ships with that allows you to run Linux subsystems natively through Windows Hypervisor. So I just have that using Kali, and then it uses WSL as the bridge to the actual Linux machine on the other end. If you were developing this on your own, like Kali Linux machine, you wouldn't have to go through all kind of these hoops. This is just kind of a way that I enable myself in my personal workflows to have Windows tooling and Linux tooling in kind of the same package. So we'll do recommended there. And then what should it include by default? I think we want read plus full action layer. one thing that I've kind of noticed is the AI likes to be lazy. So it'll recommend doing it's scoping really narrowly. In my experience with agentic development, you can basically just build out anything that you can put into words of what you want to build out. So it's usually good to just go full bore, in my experience, like let's do read and full action layer, right? Because it's not really any more work for the AI to do it or work for us because it generates the code so quickly. It's more of us being able to decide what we want into the code and make sure that it's working the way that we want. So we'll see how good of a plan it comes back with here. Wow, there we go, nice and quick. So then we can build that. Actually, let me show this. So one thing in Cursor that I've noticed that not everyone might know is if you go into the plan here, we can view plan. One, you can select what model you want to actually build the plan separately from the one you're normally running in the window. But you can also, if you click drop down here, you can click build in parallel, which will on Cursor's backend have it spawn a bunch more subagents than it normally would, and it will build it all out in parallel. For this case, we'll just build it regularly so that we can kind of talk through it a little more. We can look at the plan on how it kind of developed everything. It's got the MCP is basically acting as the middleman between the actual agent and Metasploit itself. And then it's coming down here to the WSL and Kali, and it's going to use the Metasploit database here to actually store the engagement details. That's kind of something that's unique to Metasploit. If you're building a harness that's not like a full C2 like Metasploit, you have to implement those kind of like world state systems yourself, and I'll do that this way to kind of demo it in this demo as opposed to just using Metasploit's native database. If you were building this project yourself or you want to expand the code after we make this, we'll put it in a public GitHub repo. Something you could do is you could have it natively use that Metasploit database as for storing things like hosts, IPs, and vulnerabilities and stuff like that. Let's see what it came up with. Rules of engagement. We'll go through there as well. One of the biggest challenges in agentic engineering is the fact that the agents are non-deterministic. So you don't know exactly how the agent is going to react each time based on how you prompt it. So one of the mitigating factors of that is using hooks, which is kind of baseline here. Hooks, we'll adapt this to extend it with something called like a scope hook. So we'll have a README file in the repo, which will have all the IPs we need. And then we'll have it build a hook from that scope file so that it'll check every time it runs a command with regex to make sure that those IP patterns aren't in that CLI command, or I should say are, and it will flag to us if we're attacking anything outside of our IP scope. That's kind of one of the things that I've found have kind of saved my butt in leveraging these things in production environments. So we'll let this go through. So while this is building out the basic stuff, I like to do as much parallel action as I can here. So another thing that I usually do baseline on every harness that I make after that initial research is I'll look for like knowledge base items. So since we're doing a penetration testing harness here, some of the knowledge base items that I found really useful are like payload all the things and hack tricks. Let me see if I can share my screen here. I don't think you guys are going to be able to see this. No, not easily. But so I'll copy these. Payload all the things is a primarily web-based resource that has a lot of web-based payloads and web-based attack techniques in it. And then it's got a sister library called internal all the things, which is the same kind of setup, but for internal penetration testing techniques and payloads. And then one of the greatest resources I've used for penetration techniques is hack tricks. It's got a lot of the more minutia kind of stuff that you'll find in CTF challenges and stuff like that. So I'll just feed these in here. Another thing you could do is like take CTFs. I've done CTF write-ups and have it pull from that, etc. But I'll just say, using these as a knowledge base, please clone them and begin creating cursor skills based on the information contained for our pen testing harness. So now this is kind of establishing the knowledge base level. One of the things that separates, in my opinion, a good harness from from just like running the LLMs by themselves is the ability to actually pull in this external information. So let's say if the model comes into a situation, it might not necessarily have all the techniques trained. So being able to supply this knowledge to it, the LLMs are like pattern recognition, right? So if I give it a pattern, like here's how you do Wi-Fi pen testing, and then I make skills based on that Wi-Fi pen testing, it can actually go back through and use your knowledge base to actually know how to do that instead of just generating that LLM-ly, agentically, I don't know what the word is, statistically through the models. And sorry, one moment. I actually already had us pop Defender, so I need to go through here and whitelist this directory. One moment. And that was because it's cloning Hacktricks, which has the static strings in there for the payloads. And Windows doesn't like malware. So we'll go through here.
Yeah, that's one of the things that can be a challenge when you're using Windows is setting things up where Defender doesn't delete all your payloads and tools.
100%. And that's why like running it natively on Kali is good. I do it this way partly because of convenience, but having those Windows tools open is also useful if you're doing like C# development work and stuff like that. So let's go in here. Stop yelling at me, Windows. Boom. All right, so that's whitelisted, so that should be good. So while this agent is going through and fetching the knowledge and will generate all of our skills, we can come back here and see how this one is doing. Nice. So it looks like this one is building the MCP server and tools already. A lot of what I have found agentic development to be is kind of letting it run multiple things in parallel, and then when they're done running, seeing what it did and kind of doing the bug testing phase. So we'll let those run for a second. Any other questions? Any questions I can?
So obviously you're using AI because it makes things easier than the traditional manual testing. Just kind of what are some of the benefits that you could share with using this method opposed to the traditional pen testing method?
Yeah. So there's a couple of big ones. One of them is like you hit on the logging and the notes. So literally every single CLI command that you're going to run through the engagement is going to be automatically logged for you if you're doing it through an agentic system like this. So let's say you have the client come back and say, hey, did you do X thing? You can just come back into the AI and say, hey, based on our logs, did we do X thing? And it can crawl through those logs and it can find the exact command that you would have run to do that thing. And one of the big things I like to do is make sure that it's time stamping it all, right? So when we go to develop that system, I'll make sure to tell it to also make sure it's recording timestamps for those commands. It also makes it way easier for reporting, because as it's recording what's coming in, you have everything there for reporting. So when you go to report, you can say, hey, what findings do we have? What are the remediations for these findings? And that kind of stuff that normally you'd have to crawl through your Obsidian notes and all your markdowns and look for that information manually. Some of the other big ones is just like knowledge. There's so much to know in hacking that it's almost impossible to know all the techniques. But if you give the AI, if you prep the AI ahead of time with the proper research and the proper knowledge base, the AI can contextualize all those commands, right? And all those techniques. So it'll know about NTLM relaying. It'll know about XYZ, which makes it way easier than trying to have to mentally go through your checklist of all these items that you have to do. So it looks like here it cloned these databases and it started to develop some skills. I'm going to go into and refine a bit more of how I like to do it. So how I personally let's say, constrain the model is I like to tell it to make a workflow using phases, gates, and subgates within which tie to skills. So the agent will use skills to complete subgates. Do research into the best pen testing frameworks to how to implement this. So another big thing about the agentic harnesses is there's kind of two ways of thought here that I've kind of went back and forth through. One is making like a light harness, making it so that it doesn't include all of these workflow things. And the other one is including these workflow things all up front to try to reduce some of that non-determinism. So like if you're doing a pen test, there's things you're going to do every time, right? You're going to start with an Nmap scope to get all the ports. And then you're going to identify the versions of the services running, right? And then you're going to do CVE research on all of those version numbers. And if you tell the AI to do that ahead of time, it's much more likely to follow that. And like if you give it rules files, so here what it's probably going to do, and if it's not going to do it, it's going to make sure it's going to come in here and it's going to make a cursor rule file in here where it's attaching it to every prompt saying, hey, AI, you need to follow this workflow with the gates and subgates and phases. So what you're trying to do is you're trying to decompress the whole problem of pen testing down into the smallest steps possible so that the AI can contextualize just the small step, like, how do I do recon? Okay. And then the AI goes, okay, to do recon, I need to go through the subgate, do Nmap port scanning. And then that'll link back to a skill wherein the skill will say, hey, you need to use Nmap-P-P to scan all of the ports or whatever, right? So we're basically telling the AI what to do and we're giving it the information on how to do it. Because the more non-determinism, the more you let the AI generate what it's going to do itself, the more likely you're going to get into a situation where one, it's going to do something you don't want to do, and two, it's gonna drop stuff. A general kind of failure state from these agentic systems is that they don't keep attention very well. They don't know what they've already done. So like if you have a gate that says, hey, port scan all these ports, it might port scan 75% of the ports. Say, okay, I port scanned all the ports and mark it done. So you need to like actually make sure that it's doing all of the ports and reducing that non-determinism. So then over here, so that's going to build out that. Over here, we'll say, let's build out some of the hooks. The hooks. The system. Let's implement this. Yeah. All right, so now we'll start building out some of the hooks. One of the big ones and the important ones is the scope hooking, because as demonstrated by even ChatGPT and OpenAI, the agent can sometimes do what you don't want it to do. And when you're dealing with felony level hacking stuff, you want to make sure that this is constrained as much as possible and you're doing as much due diligence as possible. Especially if you're going to run these things inside of a like client network or someone's network, because all it takes is one, if you give it an objective like attack these targets, it'll discover other targets by doing that, and a lot of the times it won't have the attention right to know that it's not supposed to attack those new targets. So let's say it goes and does DNS and it discovers a subdomain from DNS. It will likely generate the next token to, okay, now let's attack that subdomain. So you need that hook in there to tell it, no, make sure that everything is in scope. And that's using regex is basically how that's going to end up implementing that on the back end. So let that go. Some of the other things. What are some other things that I haven't hit on yet? I guess at this state, we'll just say, how are harness looking? please ID gaps in the goal versus. Actually, let me go, and at this state, we'll implement a kind of world state model for the agentic harness. Keep a markdown file of the commands run and the results, as well as the gates / subgates and whether completed or not. Please implement a hook that will hook into the CLI tool calls the agent. Check the action has already been completed. So like I said, the agents tend to get lost a bunch. So one of the most important things to implement is some kind of a world state. Here, I'm going to have it just do a markdown file of all of the commands run. And to reduce that non-determinism, it's going to create a hook into the CLI tool call to instruct the agent to look at this before it actually runs the command. That's just to have it not do the same thing over and over. In my experience, I found that the agent will lose context and do the same thing over and over and over, and that's annoying to everyone involved. So we'll let these run for a second.
Definitely seems like a good way to make sure you're getting complete coverage and staying consistent in your testing.
Exactly. And that's the way I view it. The AI isn't a replacement for that kind of human insight, level 0-day discovery kind of stuff. It's more of, okay, everything we already know we have to do, let's make sure that we do all those things as fast as we can. So like I said, Nmap, every single engagement you're going to have to discover ports. That's something that's perfect for the AI to do, right? So you can have it, so you go in, the AI will do all the ports and put it out there for you. And then you can look at the ports and be like, okay, what here do we actually want to drill into more? Because the AI, it's trained, right? So it's based on the material already out there. So if it finds something like a Tomcat web server or something that's had a ton of exploitation text, let's say, written around it, that's kind of what it's going to default to go to. And you kind of need to be the expert driver there to position it in the current context of time, really, if that makes sense, getting a little abstract with it. The agents don't have a sense of time and like what a current exploit is versus an old exploit and stuff like that. So here we can already see one of the error state failures. So our hook was already implemented and out of scope violation detected, target 888. So we'll just run these. With the IP detection and hooks overall, they're very false positive prone because they're written with regex, right? So on the first iterative pass, I don't know because I haven't looked. I guess we can look. Scope check. How big is this? All right, this is too big to look through. So it's doing regex check here. So it's going to just detect all of the IP patterns and it's going to block anything that's, 3 digits, dot 3 digits, dot 3 digits, et cetera, et cetera. So it doesn't know that, like, one of the instances I've had is where I'm doing an SNMP crawl. It doesn't know the difference between an MIB number and an IP. So that's something as you kind of just go through and use the harness, you refine over time. And there's a lot of stuff like that you don't know ahead of time that you just kind of refine over time by putting it against real world situations. Cool. So it looks like it's made our world state and some hooks. So that's good. One other thing too that's nice about Cursor, right, is you can run all these agents basically nth as you want. So you can parallelize out and contract in, and you can go to the history. So if I ever wanted to come back to the world state implementation, I can come in here and I can kind of continue. So best practice would probably be to have one agent do one thing and then kind of continue that conversation. I'm kind of juggling a lot here, explaining it and trying to do it. So I'm not necessarily doing best practice, the old do as I preach, not as I do kind of situation. So then in order to actually have a target to run this against, let me make sure I've started. I have hopefully, started a Metasploitable instance in a Docker container. If you might not know what a Docker container is, Docker is basically it's a containerization orchestrator. So containers are basically little VM machines that are running on your computer separate from everything else, with barriers and stuff like that. So basically what we're doing is we're running another web server on our computer in a little VM machine for us to attack. And one other big tip is the screenshot tool. This is one of the things that just in general across the board has drastically accelerated my AI workflow capacity. Is instead of copying and pasting something like this that might be hard to copy paste, literally just take a screenshot of it. Don't need to mark it up, and then just throw it in there. So the textual parsing of the models are so good at this point, it can parse all this information out of the image almost instantly. So we'll just say, I have spawned a Docker container here for us to test against. You please confirm connectivity. At this point, I'm just going to have it confirm connectivity while we finish building out the harness a little more. Like it's building a dangerous command gate, scope check gate. So this is just kind of all of the foundational stuff I'm having it build out. And then as we test, we'll kind of iterate more on it. But you can see just how quickly you can build stuff with AI. It's been about 30 minutes, and I'd say we're already about 50% of the way to a fully functional harness. A lot of the big things are the knowledge base, in my experience. Like being able to give it a knowledge base just accelerates things hugely, because now you can just say, okay, from this knowledge base, build skills. And we can even come over here and say, hey, do a deep audit on our skills. Please ensure we are capturing full coverage from the knowledge base. So now I can just have this run in the background while I do other things, right? So this is going to do a full audit against basically what we already have as skills, which is some, but not as much as I'd want. And then it will go into the knowledge base, right? And it'll cross compare those and make sure that we're capturing everything like zip slips, XSS injections, XSE ejections, et cetera, et cetera. And the really nice thing is these resources have command examples. So it's not trying to generate commands out of the thin air. It's actually pulling the examples that we know are good from the resources and adapting that to our target.
So just kind of curious, because I know you're building this out. So once you have the harness built out, you don't have to recreate this every time?
Correct. That's correct. And what I like to do is at the end of an engagement where you use it, right? You want to make sure you're logging everything. And in doing that, you're also kind of creating what's the word? Thread's not the right word. Kind of like a process. The word escapes me. I'm looking a trace. You're creating a trace of the actions taken by the model. So you can have that do like a lessons learned to improve the harness. So at the end you say, hey, using the trace of everything we learned, please improve the skills and the rules and the workflow and stuff like that to the harness. And in this way, you're kind of improving and you're iteratively developing something over time. And it's kind of self-improving.
Very cool.
So let's see. So it looks like connectivity confirmed. Perfect. So that's just making sure that the connectivity is confirmed. Let's see how the skill audit. And this is annoying. A lot of the time the AI will ask to do something instead of just doing it. I don't really have anything to say about that other than it's just annoying. So in a second here, let me see. Perfect. Let me make sure. So I'm just going to add this into the scope. Please make sure we are correctly. Actually, please add our demo target to the scope file. It is a Docker container. running on Windows host. Testing from WSL subhost. So the more contextual information you can give to the AI, the better it's going to perform across the board. So I could have just said, please add the demo target to the scope file. But by saying it is a Docker container running on the Windows host, et cetera, you're increasing the chance that the LLM is going to auto-magically generate the next tokens you're looking for, if that makes sense. Yeah, see, it's still going to get out of scope because we haven't done the scope yet. So we'll wait for that for a second to run. So we can see it's missing a whole bunch of knowledge here, and it's just going to go through. And that's what I've found to be the strongest thing about the AI is that parallelization. You can split the entire project into a bunch of work streams and then have all those work streams working in parallel. That's not unique to like harness generation, but just something in general. It's my internal IP, Windows IP. Perfect. So Lookalikes is going through this. And then I guess, while this is running, let's just ask it. And something to note here is the model cost. It is the token cost, right? I'm kind of doing this as a demo, not optimized. If you were doing this for real, you'd want to keep in mind how many tokens you're using, what you're actually prompting it with. You know, you want to optimize each one of your prompts to accomplish as much as you can in the least amount of tokens. But for example, since we're doing the demo here, let's just ask it, where is the status? What is the status of our Metasploit harness build out? Do a deep audit on the MCP and the cursor control harness surface. Please test against our scope test host as possible. So then these are done. It's missed a whole bunch of stuff. So we'll leave this. We can use this agent to keep building out the skills. Looks like it added the scope correctly. We'll see if this will work. I have a feeling it's going to run into issues because of the WSL layer as far as the scope IPs. Maybe not. No. The AI is very surprising in kind of how it solves problems itself. But we'll see how. Isn't in the catalog yet. Yeah, we're going to have to enable the MCP. MSF harness, enable. Boom. So then probably at least once a day, I got to come in here and be like, sorry, I forgot to enable the MCP. Please continue. Because the way that it works under the hood, it doesn't if you re-enable it, it doesn't know that until you re-prompt it, if that kind of makes sense, because it's taking the state at which you prompt it, unless it runs another CLI call to check, of course. But the easiest way I found is just to stop it, say hey, I've enabled it, please continue. Don't say sorry if you're token conscious, because that technically costs you money. It costs OpenAI a lot of money. So we'll run this. We'll let it see how it is running. So yeah, let this run through. What's been your experience, Phil, with using the AI? Have you had a chance to make many or use many agentic harnesses yet?
No, have not yet.
Fair enough.
So hopefully I can learn from you and give it a shot myself.
Yeah. And I'm going through all this really fast. Part of that is because Composer 2.5 is going through it really fast. But like I said, please jump in if you have any questions or anything at all. Otherwise, it's kind of going to be me just continuing to ramble. So it does a deep audit point, built, not connected, working. So it looks like we still got some issues. 80% structurally complete, 0% optionally verified. So, okay, so then we'll go back to plan mode, right? And we'll say, please create a plan to close all the gaps and get this working. It's working against the Docker container target. Want you to be able to run scans and exploits against the target and catch reverse shells, etc. Please reference the say third party. It's probably going to understand what that means. MCPs for a guideline on how to implement the MSF functionality. So one other big thing that I think is a huge advantage of using these harnesses is that the polymorphism element of it all, it enables you to very rapidly make globally unique malware payloads, stuff like that. And that's huge because most of detection, a lot of detection is static rules. The EDR vendors will tell you about, their dynamic rules and stuff like, but even that under the hood is still using what I would call static detection. So it's looking at like, what Windows APIs are you calling? And in what order are you calling those Windows APIs? And then they'll compare that against their known malware samples and say, okay, if you're similarly calling these Windows APIs in the same order as these other, malware APIs, okay, now we think this is malware. But what AI lets you do is it lets you, one, make like dead code. So you can just have it do like, hey, make a bunch of dummy code in this to make it look less like malware, right? And then those heuristic detections that the EDR are using are going to be less effective. You can also have it call unique Windows APIs under the hood and stuff like that. And it kind of closes that knowledge gap, right? Because a lot of this stuff, as far as like evasion and stuff like that I'm talking about, these would be like really high level skills, multiple years in the industry trying to learn how to do this. And now you can kind of just tell the AI, please do this for me. And because it has the tools at its capability, like you've given it the knowledge base and stuff like that, it can actually do it. So specifically with like exploitation, the models are trained in a certain period of time, right? So like usually a couple months back is the latest things they know from. So you're going to want to always tell it, hey, do latest research and find the latest CVEs you can for, let's say, if you're doing an internal test for internal testing environments like Windows Exchange. And then it can go and it can crawl, the CVE list almost instantly and find like, okay, here's all the newest CVEs I found for these services. And piggybacking off that even a little more. So if you build out a list of the asset inventory, right, you can then have it reference that asset inventory and then go say, hey, look up for each and single host here CVEs that might be relevant online. And then it can do that. And it's just such a force accelerant to these things that would normally take hours and hours of manual work to do, that it really, it turns the penetration testing into more of like deciding what to do, deciding what to build, as opposed to actually the execution of it.
So if you could guesstimate, so if you're taking a pen test that you did the traditional way compared to this, how much time do you think that could save?
There's kind of a couple, to unpack that question a little bit. It saves a whole bunch of time. Like, I'm not going to deny that point, right? Part of it is it lets you focus on the other stuff. So like normally you'd be spending a whole bunch of time hitting those coverage items, but because the AI can automatically go out and hit these coverage items, it lets you kind of focus on finding 0 days, finding those unique configurations and those kind of things that maybe aren't just in the knowledge base already, right? But I mean, it compresses like a week worth of activity into a couple hours, like straight up.
Yeah, it really seems like this is something that traditional pen testers need to do, because there's cases, I think we may even discuss this on uh, the recording we did with Milton a while back, talking about, you know, the efficiencies of it, but just thinking about some of these, some companies are offshoring work to lesser expensive countries, and then traditional pen test firms, consulting companies are having to compete with that. So something like this seems like it'd be a way to be able to play on a more even field, although I'm sure there are cases where the offshore work is probably using the same thing, but at least that's kind of a good way to, it seems like, to level up and be able to compete more with the cheap labor.
100%. And it it kind of, I don't want to like overspeak, but it really is the entire industry kind of revolutionizing here, because it's like you're stepping into an Iron Man suit is basically what you're doing, if you'll humor my analogy, right? You're coming to this harness, and now I want it to do something. I can just be like, hey, do it. I don't need to go spend time researching how to do it. So, what's a concrete example? So let's say I wanted to do an NTLM relay. Normally, you'd have to start responder, you'd have to start NTLM relay X or whatever you're using. You'd have to configure both of those, and you'd have to point them at your target. Well, I can just tell the AI, hey, please perform an NTLM relay attack. And if you have that knowledge base already in there, it'll go, okay, how do I perform an NTLM relay attack? Oh, okay, here's how I do it. And it will just do it for you. And that's kind of where I come back to that knowledge component. It enables basically anyone to be a higher level hacker. You're not going to instantly turn into an expert, because a lot of this is still knowing like what to ask. If you don't know what an NTLM relay attack is, or you don't have it pulled into the knowledge base, right, it's not going to just magically do things for you.
I thought the Iron Man suit was a marvelous example.
Yeah. Now that's funny. Now that's funny. Yeah, and it's just, and it comes back to just the same thing with like CTFs and the death of the CTF, like you were saying, the white paper at the beginning. It just, you can't compete. Someone working by hand just isn't going to be able to compete with someone with a harness, because they can just do the work so much quicker, and they have, all this knowledge base and all this functionality.
When you look at a lot of this, it goes back to days before there were vulnerability scanners and Metasploit, all this stuff you had to do manually, but people wouldn't imagine doing pen tests without Metasploit and some of these other tools. So it only makes sense that, we'd evolve to using things like AI to leverage what we're doing, because one of the cases too that you run into is companies need to test more frequently or continuously at best. And that's kind of hard to do using the traditional methods.
Indeed. And what worries me, and it's kind of tangentially related to this, is if we've already seen the heavy industrialization of cybercrime. You've got these darknet market companies that literally will have a 24/7 customer support for your malware as a service product. And the next kind of evolution of that is somebody writes a harness like this that's actually, like really robust harness, puts that online and sells it. And now you've got literal hacking as a service, right? Anyone can go in, pay $50, and you've got customer support and a full harness, and you just say, hey, hack this target, and it does it. And it's going to result in these companies basically having infinite amounts of external pressure on their systems, which is why I think it's more important than ever to make sure you actually know what you have exposed externally, and making sure that external stuff is locked down as hard as possible. Because if it's not exploited now, it's only a matter of time until it is. And that matter of time is getting shorter and shorter as these AIs get better and better. And that's a good thing to note here. Like, this is all just using, well, it switched to Opus 4.6 on me. Maybe that was me. These are all using old models. These aren't using, Fable. These aren't using, what are we going to have 3 years from now in terms of models? The strength in just being able to hack things, and the bar is just getting lowered so much that it really becomes more of a, I don't know. It's just a very tough battle, and I don't know what the solution is from it as a defender outside of, AI fighting AI is kind of where a lot of people are going, is going to kind of be the future of the field.
Yeah, it's pretty interesting. One of the things I can see the value into is, anytime you're doing a pen test, you need to go validate all your findings. And there's some things that are just boring but necessary, like your TLS and SSL related findings, going back, validating those and screenshotting those. So one of the things I always hated was how to go back and validate all those type of findings because they were pretty boring and it was keeping me away from doing the valuable stuff. But it was it was necessary. So I can just really see this be able to take care of all that stuff, and you're able to that 40 hours of pen testing is a lot more valuable than what it used to be.
Yeah. And that's kind of an issue too, is how do you, one, build this, and two, like, how do you record effort value on engagements like this? And this isn't just a pen testing problem. This is kind of like a consulting problem and a work problem in general. Because if I can just throw the AI at something and get it done in 10 hours, do I bill that 10 hours or do I bill for the pen test, right? And even beyond that, if that 10 hours is mostly spent here, talking to Phil while the thing builds out the actual tools and runs the engagements, do you bill that at 10 hours? Like, what if you have multiple agents running at once? Well, now you're billing multiple clients for the same time, right? And that's kind of, like I said, that's more of a consulting industry in general kind of issue. But there's definitely something that I think will need to be addressed over the coming years. Awesome. Verify ports and try reverse shell. RPC is up, add minimal tools, target is live. So it looks like it's running through here, and it might have already had it. We'll just have it further develop out our skills on the knowledge resource. Are there any kind of, so here you go. Here we can see it detected the out of scope IPs 172.2228, and here it got one with the N on there, N target. So this is what I mean by you get a lot of false positives, but false positives are better than false negatives when working with AI. So if I would recommend, as you're building out these kind of hooks in these systems like skills and rules, to reduce the non-determinality of the AI, that you make those broad and kind of rule them in as you work through it. That's just kind of been my experience with it.
So while using AI, of course, you're improving your AI skills, you're improving your efficiency. Have you actually been learning any more? Have you improved your skills pen testing wise? Just like, say, like applications, were you able to learn while you're doing this to help you be a better pen tester?
Yeah. It surfaces things. It gives you exposure, is how I would say to it, right? Even while you just watch it running command, you'll be like, oh, I didn't know that was a thing. And that lets you learn so many things so quickly just because it's running through so many things so quickly. It definitely, it's kind of like you train the AI and the AI trains you too. You get better at prompting the AI to get what you want, which I think is one of the biggest kind of takeaways from using the agentic AI, is that you learn how to use the AI, right? It's like any other tool. It's like a calculator, right? You spend a couple months in 8th grade or whatever first learning how to use your graphing calculator. You have to learn how to use the tools before you can kind of effectively leverage those to solve other problems. Then let me see, is the MCP running? It is disabled. Enable. So then, like I said, multiple times a day, I learn that the MCP isn't actually running, and I say, sorry, the MCP is now running. Try again with the MCP.
Try harder.
Exactly. And one thing that I forgot is, here we have full logging in our hooks. Here we have hooks and rules. Ensure the harness is properly recorded. Command run the time it is ran at and is properly stating world state as needed. We should have pre-flight and post-flight tool calls. The model should also assess and generate a risk score for the command above a threshold. They should be escalated to the loop. So another kind of insight here is make sure that you're doing pre-flight and post-flight rules on the CLI tool calls. So under the hood, the way the agent interacts with your computer is it's making a tool call basically through an MCP, but it's not hosted as an MCP, to interact with the CLI of your computer. So what you can do is you can write hooks. So every time the agent calls that tool to interact with the CLI, it's doing something, right? So here we're going to have it every time that it does a tool call to interact with the CLI to run a command, it's going to do an assessment of the risk of that command. So is it like eternal blue? Is it going to crash stuff? Well, then it's going to assign a score. And if that's above a threshold, then it's going to escalate to the hacker in the loop, the human in the loop. Another thing with the pre-flight and post-flight hooks is making sure that it's actually updating the world state, because a lot of the time the agent, when it gets to a high enough context, will just run the command and it will forget to actually do the rules that you've told it to do. So by using the hooks, you can implement that programmatically, so that every single time it gets that new instruction right before it runs the command to do these things. And it just kind of helps it stay on task, because like me, the AI has very bad ADHD and it will jump around if you let it. So yeah, we've got all these scope issues. So we can see them. Okay, server cursor harness. Boom. So we can see the MCP is up. It got connected, it ran the data. It got the network configs from the Docker targets. That's a big log. This payload handler aren't wired correctly, fixing that and setting up reverse shell networking. So another big thing about the AI is, like, when it finds things that are wrong, a lot of the times it'll be able to fix it itself, which is kind of just huge workflow improvement. What is it even doing here? It's just waiting. Let's see what it's doing. Search knowledge base. So here's something interesting, is it made a script itself to actually go through and search through the knowledge base for information. So it's kind of a unique quirk of AI, is that you don't know what it's going to do every time. And I can't stress enough, the main engineering hurdle here with agentic systems is just reducing what the AI can do in that non-determinism. You want to make it so that all the AI has to think about is, okay, I need to run an Nmap scan. How do I run an Nmap scan? I do Nmap and the IP. Like, you want to limit the decisions that the AI has to make as much as possible at each step. And instead of having it be like, do a pen test, you want it to be like, run Nmap scan, parse Nmap scan into state file, check version numbers on state file. You want to nuclearize the tasks as much as possible. So we're having this built out. And I don't know if we mentioned at the beginning, but this full harness we will put in a GitHub repo for the listeners to use as you want. At this point, I'm getting tired of this, so I'm going to say, please fix the scope hook. Have a false positive. All right, so there I'm just gonna, have it fix the scope, kind of partly to demo this, partly because I'm getting tired of it saying that everything is out of bounds of the scope. and that's as easy as literally copy and pasting it in there, because it can reference the code itself, because this is cursor. So then it'll go in here and it'll explore the scope check, find the false positive in the command, blah, 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 and then it will fix it for us. Get another scope violation, IP 8888. So then we can be like, even here, another false positive, please fix. And one thing I really like about the AI is my spelling doesn't matter.
I've noticed that.
Because I'm very lucky because I was the kid that always got bad spelling grades in school. So it's kind of like how they said you won't have a calculator in your pocket. Well, we do now. So yeah, we'll let these run for a second here. Let's check state of harness. I'll just say check state of harness. We'll see where we're at. So what are your thoughts on this kind of agentic hacking situation?
Yeah, it's pretty impressive. I just couldn't imagine people not using it. I mean, it's just, like I said, you just be able to expand upon what you could do manually. It's like I used to work for this bank. There were 13 of us on a pen test team. And if we'd had capabilities like this, we were only able to get through half the PCI pen testing per year. If we had something like this back then, we probably would have gotten through the whole thing, if not doing the scope more than once. Because we had some automation in place. And back then, just like some wrapper scripts, you'd run Nmap, run some other stuff that would capture like screenshots of logins of web applications, and it would take the Nmap output, upload it to Nessus as long as it didn't crash, then run a scan against Nessus. And once this is done, it would output that information. A little bit of automation, but there were bugs in it because sometimes it would crash and then you had to go back and do things manually. But yeah, if we had something like this, then that would have made it a lot easier to get through our pen test for the year.
Yeah, and that's kind of what I've noticed is it's the next stage of automation. It used to be scripting, and this is kind of the next level up from scripting, is kind of how I like to view it. If you view it as kind of like it can do everything, it just does it, you're not going to really get much out of the agentic AI systems, right? The models are honestly getting to the point where you kind of can just say, please hack this, and it will hack this. And that's why they had to disable them all, right? But the best luck is when you ask it to do the smallest task possible. If you say, hey, AI, run this command, the AI is going to run that command 99.99% of the time. This is mathematically how the systems underneath work, right?
Yeah, one of the things I can find interesting too is I could see how you could build some better Wi-Fi pen testing capabilities, because a lot of the free tools out there's some stuff that works fairly decent, and some cheap or fairly cheap commercial softwares out there. You can pay for licenses because like the community versions would come like in Kali Linux, and you could run it. But then if you paid $100 or $50 for the license, it'd do a little bit more. But I saw that there really weren't a lot of great Wi-Fi pen testing tools, and it's been quite a while since I did a Wi-Fi pen test. And I could just see how you could really improve the capabilities of Wi-Fi pen testing using AI.
Yeah. I 100%. And like I said, I mean, where we've been going for about an hour now, I mean, you could come in and you could build that wireless pen testing MC or harness in 3-4 hours to get it to probably a production level. And then, I mean, there you go. Now you've basically automated your wireless pen testing, right? And then from there, it's just refining that harness over time to make it better and better. And that's what kind of scares me as far as like, I don't want to say the field in general because it's beyond just cybersecurity, but AI in general it becomes less about doing the work, right? And it's more about what work to do. And that's going to eliminate a lot of jobs. And it's going to be interesting to see how society kind of reacts to that.
Yeah, they kind of go back to something you said earlier, because you were talking about, companies doing a test and you don't know how much time and effort they're putting into it. There have been companies that would just go run an Nessus scan, put in a pen test report, and sell it as a pen test. So that's the scary thing about having AI. Just even though you have AI, was it a good level of testing? And then that just goes to show the importance of being able to find a trusted consulting company to be able to do that. Or if you're internal, that you've got a team that you can trust, because otherwise someone could easily put something out and it may look good, but it may not be thorough, and it may just be basically a bunch of scans.
Yeah. So here, another kind of thing as far as just like an agentic engineering skill is escalating models. So here I'm just, instead of using Composer 2.5, which is just really fast, I'm throwing up Opus 4.6, which is a deeper thinking model, to just kind of do a deep audit here and identify any gaps that we can close to get this more to a production level. This is just kind of to that idea of work as many things in parallel as you can, because you can, really more so than anything.
Yeah, I like the way you did that, because you kind of start out with less expensive models to kind of build things out, and then once you kind of got things almost where you want it, then you use the more expensive token use models to build to test it out.
Indeed. So we can see here it built those hooks out for us. We've got a command ledger, we've got risk assessments, hook audit, world state, and it has validated some of these, escalated eternal blue, escalated multi-target exploits. So it looks like our hooks are working. So one of the quirks with AI is the AI always looks like everything is working when it's really not. So I found that, and I don't know how to phrase it, but putting it against real world and just getting in that real world testing and kind of not waiting until you have everything built out, but just trying to make sure that things are working as you're building them is more important in agentic development than in necessarily normal development. So then here we can come back, right, and it's going to find a whole bunch of gaps. Yeah, just a whole bunch of gaps, and then it's going to start closing these gaps. So over time, right, I can literally run this, saying, do the audit, close the gaps, 3, 4, 5 times while I'm working on something else, and it'll build itself out, which is kind of a superpower of the agentic engineering. It really does not like this VSPD exploit. So it looks like it's kind of running into an issue here. One thing I noticed is that I'm guessing this MCP MCP isn't fully built out. So I'm just going to come over here and go to the Opus model and say, hey, you do a deep audit. And another kind of prompt engineering thing is these words like deep. Because of the LLMs, how they work under the hood, these kind of adjectives like this are actually really important to getting it to do what you want consistently. In my experience, this is kind of something that you just have to use AI a lot to kind of find what those words are. So things like deep, things like production, things like expert, just those kind of qualifier words that get the AI to generate the next token that you're looking for to generate. Okay, can you do a deep audit? MCP or Metasploit, make sure we have full functionality and everything is working. Any gaps you find, please close them. We'll let that work for a sec. Port scanning against is confirmed, working versus auxiliary model plus service info. Nice. We'll reload the harness. Cool. So proof we can use the harness to exploit the vulnerable Docker container. So it looks like we've got it basically built out at this stage. More of it is just going to be testing it against and making sure everything is working correctly. Do you have any questions for me regarding the harness engineering itself, as I kind of went through that very quickly?
Yeah, nothing at the moment.
see if it can get it. And actually, let's even, and this is another kind of thing, just the power of AI, right? I kind of want this to be done fast. So let's say, hey, we are testing our agentic hacking harness using Metasploit. Can you please look for some vulnerable Docker containers and pull them and run them and test against them? So I'm just going to literally on the fly ask it to see if we can pull any other vulnerable Docker containers and have it run it in Docker. So we'll see how it works. Session tools. Manual running through MCP and diagnosing why MSF isn't capturing the session. So this is a good example, like, and it's kind of blown me away in the past 2 years, just how smart the models have become. This is Composer, right? And it's like, okay, so I ran the manual one. The manual one works. Running it through the MCP doesn't work. And then it'll figure out itself, okay, let me diagnose why it isn't working. So it kind of does that multi-level thought process that the original like ChatGPT 4 wasn't able to do. And it's just kind of crazy to me how quickly we've been able to get to that point with the models. See, here we can even find it even got the root cause, and that was like what, a minute. It was able to identify it had an issue, find the issue, and now it's going to go through and it's going to fix the issue. So that kind of comes back to what I was saying. This is really just an iterative process of just doing multiple loops of, hey, what's wrong, fix it. Hey, what's wrong, fix it. Test, fix, text, fix, as opposed to a more traditional development style where you're getting, your list of requirements. Now let me make that one function. You build it all out and you kind of test at the end. And this is more of an iterative test as you go process is what I found best for agentic engineering. So yeah, this is going to pull the damn vulnerable web app. We'll let that go through, and then I suppose we can run it against that too and see how it does. Audit summary, generate payload, read tools, agent tools, parse production, world state hooks, work on engagement template, test suites. Cool. So it looks like these are all running to do the things we need. Looks like it's still having issues. And this is where the steering is important. Because like here I can see it's having issues with the VSTPW. So I'm going to say, it looks like you're having issues with that. I can't count. Please use web search tools and any other resources you can to ID why and fix it. So I wanted to bring in here just the web search tools, specifically like that kind of keyword of web search tools or something along those lines is important, because that tells the model to actually use its web browser tools, right? So here it's looking up, it found Metasploit, blah, 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 PyMeta, so the Python for actually running the Metasploit. So it found those like instantly, right? And that's, in my experience, where one of the superpowers is just that ability to quickly web search and synthesize information from the internet. This is going to go through here. So yeah, that's kind of my demo. At this point, it's just letting it finish up and refining everything. What finalized kind of questions do you have for me as we finish out this first part? I do think that it is worthwhile to continue. We can show evasion and stuff like that in another part of the series or whatever we want to do. But at this stage, like, what do you think, Phil?
Yeah, I think it's pretty cool. It's pretty amazing, and it's kind of faster to build than what I expected. I kind of thought this would be like a multi-day process to build something out like that.
Yeah, and it used to, right? It's just the tools are just so quick now. I can't even keep up. I wasn't expecting Composer to plow through all those things so quickly, so I'm kind of just trying to talk through it as it's going through it.
It's really kind of cool to go back to what I said earlier too. It was interesting how, you were being conscious of tokens and using some of the cheaper models to build stuff out. Then once you did all that work, then you're able to go back with the more expensive models and run those to validate and maybe do the final tweaks on. I think that's a good method and something good for people to keep in mind when they're doing this, because they may not have a company with a big budget of tokens, and they may have to be more budget conscious. Or if someone's doing this, especially like if they're learning and they're doing this in a CTF environment, then more than likely they're not going to have all the budget to do that. So I think that was a good learning point there as well.
For sure. And the agentic component is kind of exclusive to Cursor, some kind of runtime, and that's really token sensitive. But as you come in and you're learning stuff, I mean, use ChatGPT. That's originally all I had to use. And I mean, ChatGPT can make you your payloads. You can literally copy and paste your CLI commands into ChatGPT and have it run that way. It's just not quite as effective, and there's a lot more friction there. But I fully recommend, like, as you're coming in and you're learning these things, to do it. Just anytime you have a problem in your workflow, try to figure out, how can I solve this with AI? How can AI help me do this? And over time, you'll just kind of build that intuition of how to effectively leverage it.
Very cool. Yeah, that was a great demo. Thanks for sharing that with me. I look forward to learning some more stuff from you, because I need to get up to speed on this myself. Because one of the things I always tell people, and I share this because it's kind of from learned experience, is you have to keep up with the latest technologies if you don't want to get left behind. And we witness that a lot. Although it does seem like people are trying harder with AI compared to like cloud, because cloud, so many security professionals really didn't seem to adopt it. And it seems like people have been more proactive to learn it. So I think that's awesome what you're doing. And it's good to see. One of the things I always want to look at, because I've seen automated pen testing products out there on the market, but the thing I was looking forward to is once this stuff gets in the hands of offensive security professionals and they learn how to make these tools, just like, using Hacktricks for an example. They've had their information out there for years and similar information out there of people shared, but like back to some of these automated pen testing solutions, some of the people building it may not have as heavy of a offensive security background, but then you take real world pen testers who've been doing this for years, and they figure out how to leverage these tools. It's always a good thing. And that's one of the cool things to see. Is I've seen in recent months people like Dave Kennedy and John Strand starting to get into the AI stuff, or sharing what they're doing. I'm sure they've probably been doing it for a while, because Dave's done a lot of coding over the years. He was one of the ones that built the social engineering toolkit. So it's really cool to see the actual professionals that have been doing this stuff for years start applying this to AI and learning how to elevate what they're doing.
Yeah. And it's very interesting to me to see, from the offensive perspective, to see kind of how the defenders use the agentic AI component as well, because it's certainly got uses there as well, like crawling logs, automated patch remediation, and stuff like that you just wouldn't be able to do prior to AI. I mean, now you can have a 24/7, always on SOC analyst basically at your company with an AI. And it's just interesting to see how they're kind of implementing the reverse side of the equation.
Yeah, that definitely seems like one area that is really got to have a lot of effort put into it, because as the threat actors are upping their game, then the defenders have got to work harder to try to block what's going on. So
yeah, for sure. And the next kind of evolution I see in all of this is, currently everything's in the cloud. Being able to move that locally is huge. And I know specifically you brought up Dave Kennedy, and I know they've been working on an internal model specifically to do that, because a lot of clients are sensitive with data going to the cloud and stuff like that.
Yeah.
And unfortunately, the hardware and the optimizations aren't quite there yet. You really do need data center level GPUs to do, effective agentic tool calling and stuff like that. But I could see in 5 years, right? You could on your local desktop computer, just run agents 24/7. And that's kind of the world we're going into. And I think getting the skills now to prepare for that future is critical.
And do you think that's really needed? Because you look at stuff like, what was it, Mythic and these other, and Fable, that were out there for a while and got pulled, different models that, someone builds a tool around it, and say all of a sudden the government comes up and say, hey, you can't have that out there. Or either the company that runs the frontier models are coming back and say, this is too dangerous to put out in the hands of people. And then all of a sudden you built this process, this automation around this, and all of a sudden it's not there.
Yeah, it's definitely a concern.
Well, thanks again. That was really cool. And I look forward to some more demos. And for everyone watching, we'll be sharing some information in the show notes, and then also look forward to more episodes like this. So when we rebranded as Hacker in the Loop, it was to be more technical, because when this podcast started out, it was under simply cyber and it was more of a career oriented channel. And when we moved over to the Suzu Labs, we were kind of going that way, and we've rebranded to be more in the true spirit of Suzu Labs and bring more useful technical information and not so much the purely career type stuff. Although there would be information useful career wise, just like the information presented today. If someone's working on the OSCP or some other certifications, it would be good to kind of work on this along the way, because a lot of people worried about getting the foot in the door. They're saying now it's going to be hard for entry level folks, but if you got the AI skills and a little bit of pen testing skills, maybe a certification, maybe you'll have an easier time, because there's senior folks out there that don't know how to use AI.
Yeah. And it's just like any tool. I mean, I was a little young for when the internet came out, but I see a lot of parallels to the internet. A lot of people are very anti-AI, and they're like, oh, AI will never work. It's not going to ever get this $1 trillion market cap that it's at, or whatever it's at. But people were saying the same thing about the internet. And I mean, to some extent they were right. I think a lot of this AI stuff now is hype. But I think the durable technology underneath is definitely there. It's like crypto. I think we're going to probably very soon see the bubble pop a little bit, but then you're going to see the kind of Microsofts, the kind of Apples, those companies come out of it that are going to withstand the next 20, 30 years and really kind of be the pinnacles of the future of technology.
Very cool. So anything you'd like to share before we close it out?
I think that's all. Just follow me on X, at HackerFriend, LinkedIn, at Jacob Krell. Follow Phil, follow Suzu Labs, and I look forward to being able to share some more of my AI engineering and AI penetration testing skills in the future.
Thanks again. And thanks everyone for joining, and we'll see you on future episodes.